So, welcome at this event, our masterclass, the collapse of the proprietary world and why open source science, why open source needs open source science education. That's the small subtitle. We're also going to talk about that. So, my name is Erik Mols and I will be giving this lecture. So, let's look at the agenda. So first I'm going to introduce our company Open Source Science very briefly. Then we're going to talk about the drivers of the proprietary collapse. We are going to talk about the education we offer, and we can have a discussion through YouTube chat. So please, if you chat, my assistant will read the chat and then afterwards I can answer your questions. So let's delve into the discussion. So who are we? Well, we are Open Source Science. We were founded in December 2022, basically because of the sustainability of open source. And later on in this presentation we'll talk more about that. But the main reason is that students leaving universities worldwide do not understand enough about open source. So it was difficult for them to start development in open source projects. So why? Then we continue on this question. We are part of a group of 122 companies which run since 2010 solely on free open source software. There's no installment of any proprietary software in one of those companies. And like I said, traditional universities don't train Foss engineers, they train big tech engineers. So let's delve into the first driver of why the proprietary system is killing itself. And for that I have to build up the story a bit. And I start here with Mr. Hollerith in 1892 and the development of the punch card and the fact that they at International Business Machines, IBM, started using the punch cards and mechanical computers for the census. And it's just a beginning point. Computers were there before. We had the first computers in the 1500s, mechanical computers of course, but this is when the data collection started. And I want to take you with me on this journey to understand the problem the proprietary system is hitting at this moment. So, the first digital computer, that would be 1941, the Z3 computer built by Konrad Zuse in Germany. And then of course you have to understand that in the early days of computing software was just copied. Yeah? There were no licensing. One developer copied the software of another, did his own contribution, it was copied again and again and again and again. So we could say that in the 1960s all software was free and open source. There were no open source licenses, but de facto the software was open source. Now, that ended in the 70s, and one of the milestones, maybe milestone is not the correct term because it's negative and a milestone has a too positive sound to it, but one of the milestones was this letter written by Bill Gates as the general partner of Microsoft. You can see, if you look at the dash, how old this letter is. But basically it's one big complaint. And Bill Gates is here complaining to the hobbyists, he calls them, that they should stop with copying software because he wants to make money. So this letter is often seen as the beginning of the rise of the proprietary software. Good. Let's continue here. So, we continue now with the Commodore 64 in 1982. Then it had its big breakthrough. It was delivered on the market a bit sooner, but this was the big breakthrough, the most sold computer ever, and we're still building up. At this moment, computers were not interconnected yet. Computers were solely devices, often with only one user, and most of the times they would only run one program at a time. There was no complexity yet. But in the IT revolution of the 19th and the 2000s of the previous century, we saw that more and more computers would come. And we came at, oh, the company has one computer, there's one person behind the computer, to a situation where we had numbers of computers. We started building networks with the computers. But also, a very important development is that those computers would get more and more software. And all the applications that were developed would need an own database to store the data from the application. And the developments of all those applications was often application driven and not data driven. And the database was looked to as something where you drop your data, and that's it. And of course we also saw tools like the object relationship mapping tools to put a layer between the application and the database so that the application could automatically create the database. Think about technologies like Hibernate or Java Spring, but also Ruby on Rails, kind of, although it works the other way around, but object relationship mapping tools where the application takes the lead and the database is a subject. Nowadays, we get all the problems because of a lot of problems because of these kind of technologies, and we have to repair a lot of things. But for the open source, it's fine because it's helping us, and that is what I'm now going to try to bridge that gap to explain you. So we have the growth of the number of PCs, applications, and databases. The result of this process is what we call an Hairball architecture for applications and data. Companies have an enormous amount of different applications with a huge amount of databases. There's a lot of double data in it. There's no single point of truth. There are no golden records. So it's difficult to maintain. But, well, if we can keep it working, it's okay for those companies. But now we are coming to a new kind of development that's happening. And that's the proprietary wishes. And I call it this in this slide the proprietary wishes from problem to solution. So first of all, the enormous growth of the data was often seen as the problem called big data. Data was a problem. There was too much data. It costs too much space to store it. It was too much cost to do the backups. Companies were often busy with how fast am I able to delete some parts of the data. And it evolved to a solution for many companies to become data driven. But to become data driven, you need something. What do you need? What do you need if you want to become a data-driven organization and you have thousands of applications with an equal number of databases behind it. How do you then become data-driven? Well, that's a difficulty. Because if you want to become data-driven, if you want to connect all those databases together, if you want to find the golden record, if you want to define a single point of truth, you need the data models of these databases. So, let's imagine you go out and you ask a couple of proprietary vendors for the data model of their proprietary program. Let's say you want the entire data model of SAP or any other application. Microsoft Dynamics, name something. You want that data model. Are they going to give it to you? No, they are not, because it's proprietary. It's their secret. Yeah, but it's your data, right? It's the data of the company, but it's locked up in a proprietary model. So how can you now create a golden record or a single point of truth if you cannot get your data model? How are you going to do that? And you don't need one data model, you need many data models. So and that's what I call the data-driven collapse of the proprietary world. This is what I call the first driver. This is the fact that moves commercial companies. They are not moving to open source because of philosophy often. They move to open source because of this driver. The fact that they cannot become a data-driven organization while maybe their competitors can. And in all honesty, I believe that if you do not become a data-driven organization and your competitors do, at the end they will succeed and you will fail. Because it's the evolution of becoming data-driven, it's the evolution of automatic management systems based upon all kind of data streams in the company. So if your competitors are doing that, you need to do that too. And in all honesty, when a lot of your programs are proprietary, you cannot do that. So that's what we call the data-driven collapse of the proprietary world. So when you then say, you could say then that with proprietary software and data models, you are not data-driven, you are delusion-driven. To really reach the point in maturity of a data-driven organization, you need connection between all the data models of all your applications to make that thing work. So, data-driven business is one of the drivers of the change moving from proprietary software to free and open source software. It's only one of the drivers, and totally today I will be presenting 3 drivers, but data-driven business is one of the drivers. So, companies do not leave the proprietary world because of philosophy. Some do, of course, some do. But they leave it because of vendor lock-in and costs, which are important reasons to leave to the open source world. And of course also, as we have seen, the lack of data management and control of the data. So if we then take a look, and this is an estimation of Grand View Research, who have some historical figures about the US open source services market, and they are expecting a huge growth. And it doesn't mean that the proprietary market is equally declining. That's just because the total IT market is growing for as long as I can remember. But we see here in this that the open source market is growing. So, okay, we are going to work on the second driver. And open source, we could say, is stimulating innovation. Why? Now, well, if you develop things together with others, collaborative development, that's encouraged by open source, because a lot of people join projects, and they can see the code from others. They can give feedback to the codes of other code from other people, will give ideas, will create new opportunities, and that is an accelerator for innovation. Open source often has a faster problem solving. If you imagine that you have multiple contributors working on a project simultaneously, issues can be identified and resolved more quickly than in closed source environments. Let's look at one concrete example of this. Microsoft used 2,500 developers for Windows 10, for the entire Windows 10 system. On the other hand, the Linux kernel has 15,000 active developers. And that's only the kernel. We're not talking about any distro specific developers and apps. Only the Linux kernel has 15,000 active developers. So the entire Linux ecosystem has a multitude of this. So now if you look at this faster problem solving, you can understand that the number of people working on an open source tool as Linux is far more than on a proprietary operating system. So you can expect then that there is more innovation. Yeah? So open source also stimulates constant improvement. The open nature of the software allows for continuous improvement as users provide feedback and contribute to its development. Closed source does not stimulate innovation. And why then? Because making profit often doesn't need innovation. If you have a vendor lock-in with your customer, why should you innovate? They are paying you. They can't leave. They need your application. They will pay you anyway. So making profit doesn't need innovation. Next to that, proprietary software is often expensive. It's limiting the availability to only those who can afford it, and that restricts innovation by preventing individuals or organizations with limited budgets from accessing the tools they need for creative work. So that's also a reason it's limiting. Proprietary software has a lack of transparency and customization. Closed source code in proprietary software means that users cannot see how the program works. They cannot modify its functionality to suit their specific needs, and that lack of transparency hinders innovation as it prevents users from improving or adapting the software for new purposes. And there is restricted collaboration and community development. Proprietary software often comes with licensing agreements that limit sharing, that limit modification, that prohibit redistribution. These restrictions can stifle collaborative efforts and prevent the collective intelligence of communities from contributing to innovation in software design or functionality. Without a vendor lock-in, companies need innovation to compete with competitors. So, if you want to compete with competitors and you want to use your software for that as a primary asset, you are hindered by a lack of innovation. You are hindered by proprietary software. Companies need the innovation to compete with the competitors. So, if you really want innovation with software to compete, you need open source software. And big tech doesn't need innovation if they don't have competition. And they want you in a vendor lock-in. They want you, your company, in a situation that you cannot leave because the data is structured in that application. You don't have a data model of that. You are locked into the application and you cannot easily change to a different platform. So you have a vendor lock-in. So they make you sign contracts. You sign a contract for 4 years. And then after 4 years, they say, well, we have a lot of costs. You want to continue the contract for another 4 years? Yeah, that's okay. But alas, we have to index the prices with 100%. Yeah, it's expensive. Huh? Building software is very expensive and we have innovated a lot. So we need to kick up the prices a bit. And companies often cannot leave because, well, you have lots of data stored at this proprietary company and it's not easy to get this data out and to transform this data, to move this data to an open source tool because, of course, you don't have the data model. So that's an extra difficulty. Yeah, that's the vendor lock-in that's happening. So how did we come so far? How did we come into a world where proprietary software became the de facto standard? While we had this good system in the 60s and the beginning of the 70s where everybody just copied software. Yes, true. But if you look at the society that was there in the 70s, the open software was not really, it was not established. It was a small group of people who did this. And if you look at all the other things, all the whole patent system, which is a huge influence, of course, and we're going to discuss that now. But to my honest opinion, the proprietary software system is more in line with the patent system than open source is. And if we look at the patent system, it's developed from the first patent system in 1474 in Venice. You then had a situation that all kind of European countries developed their own systems. Then in 1883 at the Paris Convention there came a first international patent system, and in 1976 the World Intellectual Property Organization was founded, and we got this big intellectual property patent system worldwide. Now, that it has worked always, I want to show you with this example of the crankshaft. And I'm Dutch from origin, so this is a very important example. So basically, what is a crankshaft? A crankshaft is a device which turns horizontal movements into vertical movements. And the crankshaft is discovered a few times in world history. And as we know, in the 2nd century the Roman Empire had a crankshaft. We know that in 1200 a guy named Al-Jazari in Baghdad invented a crankshaft, but they were of course forgotten. In 1594 a Dutch guy, Corneliszoon, invented a crankshaft, and that's a very important one, because maybe you know about the golden age of the Dutch Republic. That all began with his crankshaft, because of the invention of the crankshaft, the Dutch could build ships 40 times faster than the English. And that's because the crankshaft was connected to a windmill, and then a sawing machine was connected to that windmill. So on the wind power they could saw 40 times faster than the British could. So that was an important one. In 1800, James Watt in the United Kingdom also invented the crankshaft. The last two were patented, but on the own systems. The Dutch guy on the Dutch system, the British guy on the British system. So they both could be used. They could argue about, oh, I invented it first. No, I invented it first. Well, I believe the patent system is not very functional, because I think that in moments in time there is some basic global level of knowledge which is everywhere available. So for me it's quite natural that multiple persons can have the same idea at the same time and do the same development at the same time. And a patent system is punishing for this, because the one who's first has a patent, while the other one basically has developed the same invention at the same time, but just was a couple of minutes later or a couple of hours later to register it. So the patent system is hindering innovation. And we just concluded a few slides ago that we need innovation. So the patent system is killing innovation. So what I now have done, I have plotted here a nice picture from the free software, from GNU.org. Yeah, and it is the 4 freedoms of free software. For the people who don't know them, well, freedom 0 is the freedom to run the program as you wish. Freedom 1 is the freedom to study how the program works and change it so it does your computing as you wish. Second freedom is the freedom to redistribute copies so you can help your neighbor or anybody else. And the third freedom is the freedom to distribute copies of your modified versions to others. Yeah? And then if you look into this, you can conclude that the patent system is having an infringement with freedom 1, freedom 2 and freedom 3. Because the patent systems, when somebody, let's say somebody patented an algorithm, yeah? And you want to release that algorithm under open source, is that possible? Or you want to use the algorithm, you want to study how the algorithm works. Now that might be able, but you might not change it. That's not allowed. So freedom 1 doesn't go, because it's patented, you cannot change that. To redistribute copies, well, you cannot sell something which is patented by somebody else, right? You cannot do that. Or you have to pay them something back. And for sure you cannot modify it and sell it again. So the patent system is proven here not matching up with open source. So the movement has started, and especially maybe some of you know Linux saw the daylight in the beginning of the 90s and has hugely grown, not only on the server market but also on the mobile phone market. So it's logically that the proprietary industry has developed some defense mechanisms against open source technologies. One of these defense mechanisms, and you could look it up on internet, use your favorite browser or use an AI engine if you want, and ask the question, what is embrace, extend and exterminate? And then you will find a document from Microsoft where they explain the embrace, extend, exterminate strategy. What is it then? Embrace, extend, exterminate. Now, embrace means you're going to like an open source project, you're going to embrace it, the open source project. You're going to use your budgets and your people to extend it, to make it grow, and at the end, the whole goal is to exterminate it. What was in the early 2000s, we had the most used database in the world. You might know that. That was at those days, that was MySQL. And it was then, first it was an independent company. Later on it was bought by Sun Microsystems. And Sun Microsystems was later then acquired by Oracle. And what happened from the moment that Oracle got Sun Microsystems and so also got MySQL, they basically stopped development on the MySQL source code. And it was forked then, and a new fork emerged, and that's MariaDB. Maybe you know it, but this is typically such an embrace, extend, exterminate case. Okay. Another EEE is the encounter, engage, exploit. That's basically the same idea. This is the first proprietary defense mechanism. Now let's hop over to a next proprietary defense mechanism, and that's open washing. What's open washing? It's not always on purpose. Let's be honest about that. Sometimes it just happens. Open washing is mostly done by companies. It's more difficult to do it with communities, but with a company setup you could do open washing. Let's use an example of, let's say, Redis. You know Redis? The in-memory open source database? Oops, it's not open source anymore. No, they made it proprietary. They closed the source. It's forked again, but they closed the source. So that's what we call open washing. So an open source product was launched as open source, and then at a certain moment in time, the source code is made proprietary. That's open washing. Now, open washing can happen in a natural process. Maybe because of, well, you have an open source product and it's very successful, and you have built a model as a company where other companies pay you for extra modules, and you develop these extra modules and then you put them on the market as open source, and everybody who uses the software can download and install it. And yeah, one customer has paid for it, but he paid for the developing hours, and now all the code is open source and not only free to use but also gratis for everybody, right? So that works to a certain amount. And our companies who make this happen, but then they want to grow. They have big ideas. They want to become multinationals. They want to become the new Meta. They want to be filthy rich. So they need investors. So they're going to look for investors. And they find investors. Hey, well, why then? Oh, there's a software company. Everybody knows software companies make a lot of money. So they get investors. So then we have the situation that we need to answer the questions: do these investors understand what open source means? No, they don't. So imagine you get investors for millions of dollars, and then after 1 year you have to fill in your reports, your tax reports, your profit reports, the whole thing, and then you have a shareholder meeting, and then you show them the figures, and they say, hey, I invested a lot of money in our software company, and I'm not happy with the profit. How does it come that the profit is so low? Oh, well, yeah, because it's open source. What do you mean? What? Are you giving away the code for free? No, we didn't invest money for that. We didn't. That's not the reason we are doing this. No, that should be changed. But the nature of the software is not. No, you need to go and ask money, and not everybody can copy. No. People need to pay for it, and now if you offer it them for free, they can just copy the code and they can use it without paying. No, we don't want that. So that's one form of open washing. The other form of open washing, which does happen, is you have this big successful open source project, and you get a big customer, and this big customer wants you to develop extra modules for them. And you do that. And then after a half year, you get an angry phone call from them, and they're saying, what have you done? Our competitor is using the same modules that you developed for us. That we do not want. So you can have small open source projects, small open source companies which have big customers, and they are dependent on these big customers, and these big customers in fact force them to make parts of the software proprietary. And sometimes the companies go full proprietary, sometimes the companies go to something what we call an open core model, where a core part of the open source software stays fully open source, and all kind of extra modules are proprietary. So yeah, that's the one of the proprietary defense mechanisms, the open washing. So how does this connect with Foss licensing? Well, there are two types of Foss licensing, two main categories to this, which are the permissive licenses, like the MIT, the BSD, the Apache licenses. They are quite popular. It are the most used open source licenses. I even believe that MIT license is used in 40% of all open source projects. And we have the copyleft licenses, like the GPL and the AGPL. So if we now take open washing into account, then permissive licenses are more prone to open washing than copyleft licenses are. And why is that? Well, that's simply because that if you use a copyleft license like GPL version 3 or AGPL version 3, all derivatives of the software need to have the same license. So when a product is AGPL, you basically cannot change the license anymore. That's also restrictive, eh? It's also restrictive. But with permissive licensing, you just start your project as an MIT, as a BSD license. Let's say BSD version 3. Hello, Blue Sky. Don't tell, I'm not saying that they are going to do this, but it's a possibility. You start with a permissive license like BSD version 3, and then you grow, you become famous, you get millions of users, and then you fork the software, and in the new version, where you're going to do all the new developments, you change the license to a proprietary license. And that's fully possible and fully legal. And that's why permissive licenses are prone to open washing. And there are ways to work with this. You could say, I know that Nextcloud does this. They do use a permissive license, but all developers at the company are individually registered as copyright holder. Meaning that if they want to change the license, they need clearance from all developers. So that's a way to use a permissive license and still protect against open washing. Now, this is a new type of license, and this is really brand new. It's developed in Germany, and it's called open blockchain-based licensing. It's a model to ensure that the licenses are stored on a blockchain, and it's also a module that ensures that developers get royalties, basically, by smart contracts, and that they are kept motivated. So this is of course a model which could work very well for community-based development, and not necessary for company-based development, because in a company the developers get a salary, but in a community, let's say the Ubuntu Touch development, the UbiPorts community, where developers don't get paid, they're all volunteers, then this could probably be a model where there is a form that the developers get royalties. So that's the open blockchain-based licensing. So we now are coming to the conclusion of the part of the why the proprietary ecosystem is killing itself. All the drivers that we have discussed. Data-driven organizations need Foss, companies need innovation, so they need free and open source software, and the patent system is old-fashioned and anti-free open source software. These three drivers are forcing the industry to move from proprietary software to free and open source software. And we see it happening. We see it happening, right? If you look, 69.8% of the internet software and hardware are running on free and open source software. That's huge, yes? While open source technologies are less than 0.05% of universities' programs on average. It's not a scientific research done by us, but it's just comparing a dozen university programs and see how much open source technology is in that program. So this is really a big contrast. The world, the internet, is running on open source, while we teach about big technology. So now we're going to answer the question, how can open source science help? And what's our role in this story? So we are training open source DevOps engineers. That's basically what we do, who have knowledge of open source projects and communities, who have experience in open source technologies, with experience in real open source community driven projects, and with their experience locked in their own GitHub repositories, or GitLab or Codeberg. We would love to move away from GitHub, but still a lot of open source companies use GitHub. Well, of course, GitHub is no longer open source and it's proprietary. It's owned by Microsoft, but yeah, so. If we talk about the Netherlands, where we are located, we have a shortage of 70,000 programmers. They are not there, they are not trained. And it's not only open source programmers, it's programmers, shortage. It's huge. So what we do, we made a connection between projects, between our education and communities, to make it easier for students in open source to find basically internships, to find jobs. So that's what we have done, and we do this together with partners. We have a lot of partner companies. We are partnered with GitHub Education, we are partnered with Python Institute, we are academic partners of the Linux Professional Institute, we are partners of the Rust Foundation, and we have partner companies, open source companies, in the USA, in Canada, in the Netherlands, in Germany, Sweden, Singapore, Cambodia, India, and we are open to more partnerships because we are looking at a huge amount of students who need to be trained, who want to be trained, and we need to give them real Foss projects. So what you see basically is that in each year of our curriculum, and it's a full 4-year curriculum, we give students a free and open source software project which is real, and they are going to build an open source solution together with our open source partners, which could of course lead to internships, could lead to job offers for the students, but at the minimum they get a real experience in building open source software, and all the code they make they upload in their own portfolio on GitHub or GitLab or whatever, so that they have proof of work after they finished the education. So, an example of the start of a live project. As you can see, this is a live project we are still running for Ubuntu Touch, for the UbiPorts community, and with Oka. the Odoo Community Association, and it's basically an application which connects Ubuntu Touch with Odoo Community for time management. And we do this together with the company Synconics in Ahmedabad. Then we have also Monk Computing in Bangalore. We have Wanstein from Oosterhout in the Netherlands. And then we have two universities who participate in this. It's the Bharat University in Chennai in India and the MIT ADT University in Pune in India. And well, students are working together with developers on an open source project. So here you see a possible proof of work, a GitHub repository. So at the end of a study, this repository of our student will be entirely green with dots. He has put many commits into his repository from all kinds of open source partners, and here you see a lot of our open source partners on the slide. They then can prove how good they are, they can prove what they've delivered. And if they're going to look for a job, they can just share their repository link, and the companies can look into the repository and see the quality of the code that the students have developed. And when a student only has done proprietary projects, he has nothing to prove. No, zip, zero. So, well, we are almost coming at the last slide. Foss Fest Winter 2025. We are organizing a big open source hackathon, international. It's hybrid, meaning we will be live 3 days because we have a huge time zone thing. We are international, so we will have participants from the USA and we have participants from Singapore. So we are looking about a 16-hour time difference. So basically we'll be live 3 days, but it still will be only 21 and 22 February. There's a free registration. Universities can register, students can register. We are giving away 2,000 euros prize money per day to the best team. And the teams are going to work on Ubuntu Touch, are going to work on Odoo Oka modules, are going to work with the QXIP company and more, depending on the sponsors that we have. If you have an open source company and you would like to sponsor the event, you can contact us and do an offer. You will not only get the project in the hackathon, but you also have the ability to give a masterclass. So currently we have the masterclasses which are present on this slide confirmed, and the masterclasses will be given live through YouTube. Also during the hackathon, while the students are working on the code, we will broadcast the masterclasses, and we will visit the student projects to see how they are doing. We will do interviews, we will do panel discussions. It's promising. It's going to look like maybe the biggest hackathon worldwide of 2025. So, this brings me to an end of the presentation.